Hey guys, I hope you are good and I hope that the sound is better this time. So we'll be speaking about the domain name system. That's a very important part in the in networking, and you will have to understand exactly how it works, right? So in this part, we'll be again dealing about the DNS, and you have to know what is a DNS. A DNS is basically a kind of way to identify a website on the whole web, on the whole world wide web, the internet. So as you know, when you want to identify someone, for instance, you can use the in terms of the America, you can have the social security number, you can have the name, you can have the passport number, or in South Africa, you can have the ID number. That one actually defines you well as a person. So basically, you have some names that describe a server, and in this instance, you can have the University of Witwatersrand or www.wits.ac.za or this University of Massachusetts website or anything, right? So an IP address is also a 32 bits used. It's a 32 bits long uh, like name. Yeah, it's a 32 bits now long name because it's made out of four entities of each they have 8 bits. You might know it's like 92.168.0.1. That then makes 32 bits, where this is the IPv4, right? And the IPv6 has 64 because we're increasing into the number of items in there. So basically, how do you map an IP address to a name, or how to map a name to an IP address? Remember, when you type in an IP address like 127.0.0.1, this is localhost, right? And it has to understand something. So what do? It's like we go to a domain name system that basically tries to understand the meaning of your IP address, decrypts your IP address or decrypts your name to get the IP address out of it, right? So you give it a name, www.youtube.com, and then the domain name servers goes to a database and tries to get what is the closest IP address that corresponds to this youtube.com, and then gives it to you. And it's in the application layer that it does that. Like it's basically on that, and then it goes to the network layer and all of the link and all those stuff. So it basically tries to understand that at the application layer and sends it to the link layer. Say, okay, go and fetch that particular guy. And I'm sure when you type in some websites, right, I'm sure you would see it quickly shows you a name, a very long name, and then it goes back to the name that you give it, right? And for your own understanding, there are some public South African domain name services or domain name systems that you can go and check at this particular website. There are just two, but it would be nice to go and look at that. All right, so I drew this little picture to show you basically how the domain name system works, right? So let's assume that we are a student and then we want to basically get to witsac.za. So what we do, we type in www.wits.ac.za. That's what we type on our computer. We say, go and get wits.ac.za. I don't care where it is. I don't care what the IP is, but then just go and get it. So what it does, it gets basically the very last part of the IP of the URL, right? And then it gets that, and then it gets the name, and after that, it will return your IP address. So it has to go to a DNS server and say, okay, look, I'm looking for an IP address that has a name that goes by www.ac.za. Can you give me the IP address of that one? Then the domain name system gives it the IP address and then queries wits.ac.za, and we can have now TCP/IP communication between those two because the name has been resolved, right? So, but that's basically it in a nutshell. All right. So, the domain name systems, basically, what are they there for? So, the domain name systems are, again, they there for the IP address translations. Remember, each and every website have an IP address. And if, for example, I decide to go to the terminal and then I type in the ping www.vits.ac.za, you would see that there was a quick mapping between www.ac.za and this particular IP address, and you see it's a 32 byte. But then I'll have to tell you that yeah, and some people would say 32 bytes, 32 bits. So this is 32 bytes of data, but then this IP address is a 32-bit address, right? But then that was out of the point, so that no question comes 32 bytes, but you mentioned 32 bits. Yes, so this is the amount of data brought in, and this is the IP address. And I have to mention this IP address has been cached because I access that website so often that the IP address is very close. But then if we try up dot, okay, I also access that. Let's say ul.ac.za, then it's pretty quick as well. And now that one needed to be basically uh, go and queried for, right? It needed to be queried for because I never actually accessed the University of Limpopo website. But then now I'm asking for the IP address of that particular one. All right. So we have that. We have the IP translation part, right? And we basically have it. Now, if we're speaking about some of the quick services, we have we have host alias. So what it does is like I said, you can have sometimes very long websites. It's like you type it there, youtube.ac.za. But then if you remember from the previous lectures, we are speaking about content delivery networks. So those are little servers like or cache servers. They are very close to you. They do not have the same IP address that you requested, but then because of host aliasing, it's saying that okay, you're looking for youtube.com, but then youtube.com for this particular instance is linked to that very long one. That very long one for that instance is linked to a particular IP address, and then yeah. So that's what we call a canonical name. So it's the real true name of the IP address that you're requesting, and then it's a very long one, and the DNS server basically um, resolved that. Now the mail aliasing is like okay, it's saying that for instance, your email address at WITS is your student number at students.wits.ac.za. Students.wits.ac.za, it's an IP address, right? That IP address is basically this is what you see. But then when we try to resolve your email address, right? We don't resolve it as student.vis.ac.za. It goes and get unpacked somewhere, looks for the student mailbox of VITS and looks for that particular entity in there to then speak to the DNS servers like who is the owner of this particular email address, and that is done through DNS lookup. And then the load, and you basically have the load distribution. Obviously we have multiple requests every minute in the world, right? So we have to distribute the load across multiple servers. That basically brings us to our next point. It's like, why not centralize the DNS? Why not putting it at a single place so that we have maybe quicker responses or quicker stuff. Things will not be quick if you have a unique DNS server. The very first reason we have a single point of failure. And if we have a single point of failure, that is bad because the server will crash. If the server crashes, and that's basically where all the requests go, then the internet will crash as well. And now we have the traffic volume. So basically, we have multiple, like 100,000 millions, billions requests going every day for the internet. So if we have a single DNS server, it will crash, nothing will work, and it goes back to the very first reason. If we have a centralized DNS, there is no point in the world that will be closer to everyone. It will be closer to some people wherever it's hosted, but then you'll be further away from multiple other people, and maintenance will be so difficult. Let's assume that you have a database, right? And then you have multiple things to change, but then not everything, right? And then you want to change a particular line in the database, and for example, or you want to change a column in the database. If you want to change a column in the database, you've done database before, it's what we call, if you want to alter a database, you do alter, right? And if you add a column into a database using alter, and then you have billions of rows into that table, then that's a disaster. Good luck with that. So these are the main issues why we do not have a centralized DNS. And the main thing, if it's centralized, then it won't scale. And if it doesn't scale, that will be a big issue. And Comcast is a DNS server in the United States, and then by itself, it has 6 billion DNS queries a day. Remember that the DNS query is exactly what I've done in the terminal. What is the IP address of this particular website? All right. So now we're going to the DNS. We're speaking about how it works. So how does the DNS work? The DNS has three ways. Has three levels. The very first one is the root level. The root level server basically is that server that has how can I say it? It has the bigger mapping of all your websites, right? The root server doesn't do that much, but then it tries to locate what is the closest top level domain based on this particular IP address. So when you send a request to the internet, it goes to a root DNS server, right? It goes to a root DNS server. The root DNS server now has to try to understand your IP address. So try to understand your URL, all right, or your website, your address. What is your address made of? There's a top level domain. Like when you want to understand a website or a URL, an address, you have to go from the rightmost to the leftmost. And in our instance in South Africa, we have multiple top level domain, and the end of it is ZA. That means we are in South Africa. There are some websites that will end up by .com, but that are still in South Africa, right? But then let's speak about ZA. Then ZA associated basically with AC means that we going for an academic top level domain. This is an academic top level domain. We have .co, we have a corporate top level domain. CO, whatever, fnb.co.za or whatever.co.za. This is a corporate top level domain, right? So www.vits.co.za, it goes there. Okay, you're looking for Vits, right? But then let's go to the service like, okay, do you know anything that has .ac.za? Yes, yeah. And now .ac.za, it's a couple of things like academic institution. And from there, and then we'll go and get vits.ac.za. That's exactly how it works. Go to the root level, look for ac.za, go to the top level. Okay, Yeah, there was a little mismatch here. Let's assume that we speaking about widths. In this instance, we're speaking about widths.ac.za, and then we're speaking about widths.ac.za. In mine, I was having taken out, but taken out, it has .com, and it wouldn't make much of a difference. Okay, let's roll with widths.ac.za. That's the best example. So, and now when you go down to widths.ac.za, there are some DNS servers, and obviously those are not DNS servers. And in fact, we can assume that widths.ac.za will have the DNS like that. Same for Tshwane University of Technology, DNS.tut ac.za, right? All right. Don't worry, I guess that will be the last change. So the domain name, the authoritative domain name here will be dns.vits.ac.za. Although we'll see in Wireshark that it is not the case, right? It is not DNS. It's some other name, right? Cool. So as you can see, we have some public and widely used domain name systems. And for those who will do networking in the future, you would basically use some couple of them, right? The most widely used one is basically Google, right? The Google with this particular DNS. Most of you, I'm sure, the gamers know about this. Some of them will be using Cloudflare, like most of the universities, yeah, and the rest of the world use most of these guys, right? So it depends on wherever you are, and you would use your particular DNS server. All right, so in the world, we have basically the internet has 13 root DNS servers, 13 of them, and most of them are located in the United States, right? But as you can see, you have the United States of America and Canada. You have some parts in Asia. You have some parts in hopefully it's Brazil, and then you have a bit of them in Russia, Australia, I guess it's China, stuff like that, right? So you have to understand that these ones basically manage the whole internet, right? The root servers are the one hosting the biggest part of your queries. And as you can see, we also have a couple of them in South Africa. That makes the querying fairly easier. And basically, out of this discussion, you would see that most of this part in Africa, most of that part does not have servers, which means that whatever request you do in most of these countries will go to the closest server you can have, right? And as you can see as well, most of those servers are also close to the ocean. In other words, they are very close to the internet cables that link them to some other countries. Those are just external discussions, and it will be up to you to go and investigate, first of all, why these guys do not have servers, and why some countries around here also do not have servers while they are very close to the ocean, right? All right. Now we'll be speaking about here we are speaking about the root name server. And the root name server, they are the biggest servers you will get. They are the entry of your request when it comes to URL opening, right? You want to open a URL, you want to make use of it, right? Now, when a request went to a root server, now it has to go to a top level domain. When it goes to a top level domain, after the root server received the request, it says what server, what top level domain is responsible for this particular type of servers, right, or this particular type of name, then it has to resolve that particular name, like within its context, right? We are here on ac.za. It's an academic context that we have to resolve, right? And you have some other ones. You have the Chinese one, you have the UK one, you have the French one, whatever the case is, right? And after that, we have to go to the authoritative DNS server. We have to now go one level down, which server itself hosts VITs in the ac.za context. Then you will go to the organization DNS server. In this case, we assume that is dns.vits.ac.za, and then it will resolve that vits.ac.za for you. And the root server will now send you back the IP address of the particular DNS you requested, and you will make the communication between you and VITs going through the root server after the root server made the communication, but we'll speak about that in the next slides. So let's quickly speak about local domain name systems, or systems here. So basically, local domain name systems, they're basically local, right? Like the let's say you are in WITS, right? You are in the University of Witwatersrand. Sorry, I like to take that example because we are from WITS. You are in wits.ac.za. You have to know that WITS has a local domain name system. Just understand example. So when you are outside WITS, right? The IP address is 146 and blah 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 blah. But then when you're at WITS, you have to notice that the IP address starts by 10 and some other things. So when you basically querying the server for a particular computer in the network, for example, you want to get to the cluster computer for those who are doing high performance computing. And even if you are not doing that, for example, you're looking for, I don't know, let's assume that Moodle has a server at WITS. If Moodle has a server at WITS, you will do moodle.vits.ac.za. And if you do that, then the domain name system will try to resolve this type of IP address with this type of website to this type of IP address within the local domain name system of the university or of the internet service provider, which is in this case the university, right? So you have to understand the difference between the local, which is for an institution, and what is not local or it's global, that is for the whole world, right? That's basically that. And we'll be speaking about the local cache, which is similar to the global cache that will give you the best of effort until you have updated the cache with the new location of the IP address or the website that you requested, right? And remember from the previous slide, the cache server will act as a proxy between you and the actual server that you're trying to query. All right. Cool. Now, how does the URL resolution happens, right? How does the resolution URL happens? Let's assume that we're looking for the engineering.vits.ac.za, all right? We basically we are in the engineering department, right? But then we want the IP address of gis.ukzn.ac.za. Wits is in Johannesburg. UKZN is in Durban. Those are two different cities, but then in the same country. And within the same country, they have the same top level domain, right? But it doesn't matter. We still have to look for UKZN. This UKZN is not within the WITS environment, the WITS context. So what does it do? It goes to the local DNS. And the local DNS will say, okay, you know what? I don't know this website. It's not within WITS, but then let me ask to the big guy. The big guy is somewhere in the world, and as you remember from here, if I basically clear everything here, or the most part. So as you can see here, South Africa has as well has some root uh, 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 basically has some root servers when it comes to DNS, right? So what does it do? It goes to one South African root DNS server and says, okay, cool. I'm looking for UKZN because I'm looking for ukzn.ac.za, and the root server is like it goes there to the local one basically, and after that it goes to the root server. I basically want the ukzn gis ukzn.ac.za. So what it does, it says that, okay, you know what? I don't know that one, but then I know that I can bring you down to the top level domain, right? I know it's top level domain, so the root DNS says, okay, fine. I have the URL, and what it does, it just takes ac.za and brings it down to the local DNS. The local DNS says, okay, cool. I have now ac.za, right? And then it speaks to the top level domain name service or domain name system, says that, okay, cool. I know where UKZN is, and then I can direct you to the DNS of UKZN. And what it does, it brings it to the domain name of UKZN, and then within the domain name of UKZN, it retrieve now the domain name of UKZN, send it back to the server, and then the server now has the domain name of UKZN, and within the domain name of UKZN, then it can look for the GIS page or GIS websites that he or she wants. That's basically how it works. And in this case, we call it basically iterative queries. This is an iterated query, but then because of these back and forth, right, it's iterated and also iterative. It's iterative, it's also recursive. Recursive because we're doing some recursion internally here. But then now we'll be seeing a full recursion query. That's a full one. And you would see that it's a bit heavy. So what it does is like, okay, cool. I'm looking for, okay, another example. I'm looking for, now we're going to the United States. I'm looking for basically the computer science department, right, of the University of Massachusetts. And then in the University of New York, right, it's saying that I do not have that one. Then it goes to the root domain server, and the root domain server says, okay, I don't know that one. I'm sorry, I know the top level uh, basically the top level DNS server of that one. Then let me go and look for that. In the meantime, this guy is waiting, right? While he's waiting, the top level domain DNS will now go to the University of Massachusetts DNS. Say, okay, we found you, we found the page we wanted, right? Now what it does, it goes back to the TLD, it goes back to the root domain, it goes back to the local, and then it goes back to the user. That's a whole load of this guy, right? Basically, this guy, or starting from here anyway, because this guy has to wait, and you also have to wait for all of these dance to happen, and then you go down here, right? Although it's not also part of the lecture, but then what happens if this one crashes? Just go and find it out. It won't be too bad, but just go and find out that one, right? Now we'll be speaking about caching, updating, and DNS record. Okay, so as you remember, caching or server cached, a server that is cached is a server that's basically sitting in between you and the actual server that you want to get. So this is you here, all right? This is YouTube, and this is the cached server, and usually is hosted by the ISP, the Internet Service Provider. So because YouTube is basically cached here, right? So you will be interacting with the cached server, right? But then I remember some student asking me, okay, cool. How does the cache server knows about the right website? There's something what we call a time to live that would tell you how long that particular page or that particular cached content should die, right? And after that, the cache server will basically pull it again for you and for any other one that would look for that particular server. That's what we're saying, out of date translation, right? But then when something is out of date of translation, or when something is not well updated, it'll give you the best of effort, right? It'll give you an outdated page, but it will tell you somewhere that this is an outdated page. Then you either you pull it again, or it will pull it again whenever it has the best page for you, right? Remember that we are saying that domain name service or the domain name system is a database. A database is a collection of entries. So you have an index, or you have a column that describes the other columns. That's what we call an index column or a primary key column, right? Each and every entry has a name, a value, a type, and a time to live, right? It has a time to live. Also, remember that each and every entry in a DNS is called a resource record, or RR, not Red Ribbon in Dragon Ball Z, but the resource records, right? Right, cool. So now you have the name. You have the name, which is basically the website that you're trying to access, www.youtube.com. You have a value. The value depends on the type, right? The value really depends on the type. And the time to live, it's also one value that is described in seconds, milliseconds, hours, whatever. But let's deal with the type. So if a website is of type A, then the RR format will be the name and the IP address, which is the host name and the IP address, type A. And don't be surprised, there's also type AAA. There are multiple types, and all of those types, I'll 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 give it to you in a website. We have type NS. It's the same thing. The name is the domain, right? Right? The name is the domain name here, and then the value is basically the authoritative name of the server. Authoritative name of the server, which is the domain name system of the particular server. In our previous instance, the domain name of VETS was dns.vits.ac.za. We have the C name, right, which is canonical name, which is the long name. So let's assume that we want to get IBM, right? The name will be basically the basically it's an alias for the canonical name. The name is ibm.com, right? And the value is the whole real big name of that particular website, which is IBM. And MX is for mail servers, right? Gmail.com, or let's say, oh yes, a good one, student.vits.ac.za. Do you know what it maps to? It maps to Gmail. Thank you. Or you can thank me later. All right, so this is the fun part, because this part is very related to basically what I'll show you now in Wireshark. So the DNS protocol message, right? A DNS has two and only two types of protocols, or I would call it protocols. It has a query, and then it has a response, or as known as a reply. But then in the internet world is been called response. And then it has a format that we will see very soon, right? These first three layers, they basically the identification, the flag, the questions, the answers, the resource record, and some other resource record. They all are 12 bits, 12 bytes, 12 bytes. So this is bits and this is bytes. There are 12 bytes, right? And I have to mention that each and every element, I mean, the identification is the unique identification for either the response of the reply, the response or the query. You have different flags and the questions related to that. So they say unique identifier to this particular to this particular query is basically the identification, right? And you have to be mindful of that. That's the identification. And when you're dealing with these in a Wireshark, you have to deal with that with the identification part, right? Okay, so you have a question, you have an answer, you have all of these things that you would see. Those are just numbers. They are numbers of questions, numbers of answers, numbers of authority, numbers of additional information that you get either into your query or your reply. And in networking, when you're transferring messages like that, and then you're unpacking stuff like this, we say you unpack a what we call a payload. This is also additional information I'm giving you. Right. So as you can see, the question, what is the question about? The question is about the name, the name and whatever you want from the query. Give me the IP address of or resolve for me the URL of takealot.com. Now do you have the resource record? Like what responses do you have for me? What can you provide me as an answer that I can consume, right? What is the record and what are the other information you can give me about the request, right? But we basically most interested about the answer, right? This is what we want. But then for that, that's basically what we need. Okay. Now, if you want to insert some records into the domain name service, that's for your own information. You just need to register your website into a DNS registrar, right? I mean, there are multiple of them. And after that, they will ask you to basically provide a resource record about that. The name, the value, the type, right? The name, the value, and the type. And you see that it's of type A. Obviously, we have the name, which is the host name, and then the value, which is the IP address of your particular website. And after that, you create an authoritative server locally for your ones. Like if you create a company and you see that it has one, means that it's a server, like 127.0.0.1. This is localhost server. So this is a server, and then you would like to have some, you would like to be reference to that when we're looking for some lookups. This, when we're doing the lookup for the IP address, then we get the type A. When we're looking for networkutopia.com, then it goes to the DNS networkutopia.com, and it has to resolve to this particular server, right? And if we're looking for the mailing service, then it has to resolve to whatever type your mailing service is, right? Okay. Now, that's also pretty informative. We'll be speaking about the DNS security. As any service you will find online, phishing, stealing of information and all those stuff, there is also security issues in those servers, right? Those servers are very vulnerable to traffic filtering. Wireshark is the best in that, right? Uh, you can have impersonation, you can have phishing, right? You can have all sorts of bad things that can happen into a DNS server, and then it will impact the whole internet, right? And for instance, we can have a man in the middle. which is a someone that impersonates a DNS server will make you think that it is the DNS server and will redirect you to any other website with the value that you gave it to youtube.ac. Sorry, youtube.com, and then will send you a page that looks like YouTube, but then it's not YouTube, but then it says that, yeah, no, yeah, this is YouTube. That just go for that, and then you will be basically hacked into, and you'll be open to all of these hackers with whatever they have for you, right? Okay, so this is the end of the DNS part of it. The next lecture will be about peer-to-peer applications, and right after this, I'll show you a little practical part of what I was speaking about when it comes to about when you speak about DNS URL resolving, or when we try to resolve a URL using a DNS server. Thank you very much, and have a good time studying.